Hello friends, welcome back to another video from C Field Academy. So today's topic is bubble sort. This video is part of the series of videos we are making for popular sorting algorithms. So we are creating videos to describe the sorting algorithms, and also we take an example and then go into detail to describe it. So make sure you look at the other videos we have related to sorting on this channel. So let's get started. So these are the subtopics we are going to cover today. So we will start with a very basic introduction of sorting algorithms. Then we will see what is the basic idea behind bubble sort, and see the basic strategy what it uses to sort. Then we will go ahead and see the actual pseudo code for the bubble sort algorithm. Then we will apply it to an example, and actually we will discuss step by step in very great detail. After that we will see the performance of bubble sort, what is the complexity analysis, how it performs under worst case, best case, and average case. And finally, as always, we will end with a short exercise for bubble sort for you guys to try it out. So cool. So first of all, what is sorting, or what is the sorting problem? Let's go into it a little bit in detail. So sorting is probably one of the very simplest or the basic problems that's discussed in data structures and algorithms as part of computer science. So sorting can be arranging a set of numbers in ascending order, or it could be arranging a set of words in lexicographic order. So for this video, let's assume that we just have a set of n numbers that are given to us, let's say a1 to an, and they are in arbitrary order, not necessarily in particular order, and the output of the sorting problem, or the output that is expected, is a ordering or reordering of the given n numbers such that the numbers are in an ascending sequence. So which means if we reorder and the numbers are a1 dash to an dash, a1 dash will be less than equal to a2 dash, which will be less than equal to the next item, and so on till an minus 1, which is the second last element, is also less than the last item, which is an dash. So essentially, in simple terms, just sorting a bunch of numbers in ascending order. So coming to bubble sort now, what type of algorithm is bubble sort? Is it and what strategy does it use? So bubble sort, as other simple algorithms which you might have already seen, which is basically insertion sort or the selection sort, which are already discussed in other videos if you want to look at it. All of them build the sorted array with one item at a time, which means every time we pass through the entire data, we build our sorting output one element at a time, and then at the end the entire data is sorted. So the basic idea here used is we just bubble the maximum element to the end of the array. So let's say we have a unsorted array here, and with some numbers, what we do is we start from the first element, and then we first compare the first two elements, swap the maximum and put it in the second position, and then we compare the next two elements, which means the second element and the third element, and then move the element maximum element to the third, and we keep on doing it till we get the maximum element at the end, which means essentially we have bubbled the maximum element to the end of our array. And once we do that, now we have one item is sorted and the rest of the array which remains is still unsorted, and we will repeat the same process over again. We again bubble the next maximum element which will stay here, and slowly what we do is we reduce the size of the array. So this is the basic strategy of bubble sort. So at the end we have the sorted element, and bubble sorts property is it is a simple, very simple, intuitive sorting, and it can do it in place, which means we don't need any additional data. It is a stable sort. Stable sort means data or key values with same keys with same values remain in the same order as they were in the original unsorted array. But it is not online, which means it cannot sort streaming data, that is data that is continuously coming. If you guys want to understand these properties a little bit better, I would recommend you to look at the other video we have on the channel, which we will link it up here. Is the sorting algorithms description, where we give a very brief, very good overview of the sorting algorithms, how we classify them, the different complexity, and how we compare them. So alright, let's move ahead and then see the basic strategy of bubble sort. I think partly we already discussed, but just to reiterate it in steps pretty clearly. So first step is just take the first two elements. So we are given an array, just take the first two elements and move the larger element to the second position. So we just do a simple comparison and swap those elements so that we have the larger element in the second position. Then we compare the second and third element and move the larger element to the third position. So now we have the maximum element in the third position. So we repeat this process till we have the largest element at the end of the unsorted part. Finally, once we are done, we decrease the size of the unsorted part, so which means the unsorted part now has one less element than previous, and we repeat the same process, which means we bubble the element again, and we keep doing it till we are left with no unsorted elements. So let's say we have an array here and we are bubbling elements. So what we do is, in a particular pass, we start from the left part is unsorted and the right part is sorted. So first we'll compare the first two elements and keep the maximum element in the second position, then second and third, then third and fourth, and we continue doing that till we reach the end of our unsorted array. Once we reach the end of our unsorted array, we are done with one pass, so which means we now have one less element in our unsorted array, and then we can repeat the same process with the unsorted array, with the remaining array. So this is the basic strategy behind it. I hope this description was clearer enough to explain the basic idea, but let's see, we will anyways try it with an example, so things will be very much clearer in the next few minutes. Now let's see the actual pseudocode of bubble sort algorithm. So the pseudocode of bubble sort algorithm has 7 steps in this case. The first step, what it does is, it's just an assignment, which means we store the length of the array in a variable n. So n is our basically size of the input variable. Then we have a variable j that runs from I to n, which means this is basically a for loop, the outer for loop, which actually consumes the entire code within it, which is 3 to 7. And what does this for loop do? So what this for loop does is, in step 3 we have explained, we push the maximum element from a0 to n minus j plus 1, which means if j is 1, so we have to push the maximum element from 0 to n minus 1 to n minus j plus 1, which means to an. So basically what we do is, this should be a1, actually it shouldn't be a0. So we are assuming that our array starts from 1, so we push from push from the first element to n minus 1th element, to n minus 1th element, and then we actually replace that to an in the first iteration, and then we increment our j, which means we reduce the size of the array, which means j gets incremented, and then we repeat the same process, which means in the next time the loop runs, it will be pushing an minus 2 to an minus 1, so 0 to an minus 2 to an minus 1, and so on. And what do we do in the inner loop? Let's see. So we have an inner loop, which is the inner while loop over here. So inner while loop over here. So in this case we have another variable I that starts from 1, which means the first element of the array, and while the first element of the array is less than n minus j, which means till we reach the end of our unsorted part, what we do is in step 6 we compare ai with ai plus 1, which means we compare adjacent element and we swap those element if we see that the element is out of order. So in the inner loop, which runs from 1 to n minus j, we bubble the maximum element to the end of the array, and then what happens is I gets incremented, we compare the next two adjacent element, and we keep doing that till I reaches n minus j. Once I reaches n minus j, now we have to decrement the size of our unsorted array. So that happens when we increment j to the next value, that is j gets added to the next, incremented to the next value. So let's see how it looks like. So here is our array, and we have, you know, unsorted part and the sorted part. So which means this is for j is equal to somewhere midway, it's not the first iteration. So our n minus j plus 1 points to the last element in the unsorted array. We start from I equal to 1. This is the inner loop. We compare the two elements ai with ai plus 1, and then swap those elements, which means the maximum element now remains in the I plus 1th position, and then we increment I, which means we move forward like this. So in this case we have moved forward, fast forward, and I keeps moving forward, and the maximum element gets pushed till we reach the last value of our iteration, that is when I reaches n minus j. So in this case our maximum element of the entire unsorted array comes and remains at n minus j plus 1, and once we reach there, then we reduce, or we increment j. Basically we increment j, which means n minus j plus 1 is reduced, and then we repeat the same process over again. Cool. So if this was a little confusing, let's apply it on an example, because that will make it very much clearer, I believe. So let's see a concrete example. So I have the algorithm on my left side, and we will just apply the algorithm, you know, step by step to this array. So this is our input array, which has a bunch of elements, that is about 9 elements. So every time what we do is we go through a iteration of j, which means every time we have pushed a maximum element to the end, we call it as an end of pass, or we call it that we have made one pass through the entire array, which means we compared all the elements of the entire array once. So let's start to sort this array. So this is the first pass, which is pass 1, which means j will be equal to 1 in this case. So we start from, so step 1 just says n is length of a, so I'll just ignore. So in the step 2 we assign j equal to 1 to n. So in this case j starts from 1, so first step is j equal to 1. So j now points to the first element of the array, which is 9. Now if j points at 9, n minus j plus 1 will be n minus 1 plus 1, which is n, which means n minus j plus 1 will now point to the last element of the array. So I have just a pointer here to just show, because this is our end point of our pass, that is our pass will end when, you know, we start with I and then we reach there. So next is I equals to 1. So we are step 4 now, where we assign I equals to 1. And now let's go into the inner loop, which is step 5 to 7. We start with now you can see the inner loop is I less than n minus j, which means I will start at 1 and end here. This point is n minus j in this case. And what we do is in step 6, if ai is greater than ai plus 1, so ai in this case is I points to the first element, so ai is 9 and ai plus 1 is 2. So notice what is happening. So ai is greater than ai plus 1. Why? Because 9 is greater than 2. Now since 9 is greater than 2, what we need to do is we need to swap the two elements. So in short, what we are doing is intuitively we need to keep the maximum element at the I plus 1th location. So what we do is we need to do a swap here, and after swapping our array will look like this. So we will have 2 and 9 swapped, so we have 2 and 9 and everything else stays the same. Then we move to step 7, which means I will now be incremented, I equals to I plus 1, so we will have I point to 1 plus 1, which is 2. And since this is the inner loop, we go back to step 5 again, and then we see that I is still less than n minus j, which means I hasn't reached the end point yet. I's end point is here, so which means we have to again go and do the comparison, which means we go to step 6 again, where ai and ai plus 1 are compared. So in this case ai is 9 and ai plus 1 is 7, and notice even 9 is again greater than 7, so which means we need to again do a swap and replace 7 with 9 and 9 with 7. Essentially the maximum element 9 moves to the 3rd position. So let's do the swap. So we do a swap and we end up with this array, so which we have 2 7 9, and rest on element stays the same. Now we go to step 7 again, which means we increment I to the next value. So I now becomes 3, it was at 2. And now step 7, and we repeat the loop again, which means we go to step 5 again and see if I is less than n minus j. So I is still less than n minus j because I is at 3 and n minus j is actually points to here, n minus 1, and sorry, yeah, n minus j, and yeah, n minus j. So notice what is happening here. So what happens is now ai and ai plus 1 are again compared, and 9 is greater than 4. So since 9 is greater than 4, we need to again swap the two elements, and we will have 9 element at the 4th position. So we again go to step 7, which means we increment I again to 4. It was 3 earlier, and we will go to step 5, and we have to compare I with n minus j. In fact, I is still less than equal to n minus 1. So we will now go to step 6 again, where we compare ai with ai plus 1. ai is 9 and ai plus 1 is 3, so 9 is greater than 3, so we need to swap these elements again. So we will have a resultant array where 3 and 9 are swapped, and then we go to step 7, where I is incremented to I plus 1, so I now becomes 5, and we go to start of the while loop again. I is still less than n minus j, j is 1, remember, so I is still less than n minus 1 because I is at 5. In our case n is 9, so I has to run till 8, so I has to run till this, which means again we go to step 6 and now compare ai and ai plus 1. ai is 9, ai plus 1 is 11. Now see what happens this time. Now because ai is 9, 9 is not greater than 11, hence the if condition will fail here, so we no need to swap. So basically what we are doing is, when we compare 9 with 11, we know 11 is the greater element, so there is no need to swap, which means 11 is already in its position. And what we do is we now go to the next step. In this case again we increment I. Now I was 5 earlier, I becomes 6, and notice the maximum element 11 is bubbled to the 6th position now. So next we compare 11 with 6, and notice 11 is greater than 6, so we have to do a swap. The if condition passes, so we swap it, and we will end up with this array. So 11 now becomes the maximum element, and that is at position 7, and I becomes 7 now. Cool. So now what happens is we again compare AI with AI plus 1. So 11 is greater than 5, which means we need to again push element 11 or swap them. So we do the swap, and we end up with this. Now notice what happens in this case. Now we go to step 7, I gets incremented to 8. Now what happens is we go to step 5 again. So I is less than equal to n minus j, which means 8 is still less than equal to 8. So we will compare element 11 with its next element 10, AI with AI plus 1. 11 is greater than 10, so we again need to do a swap. So we'll swap it, and now we have 11 at the end of the array. And notice what happens, I now points to 9. So I has now become 9. So what will happen is we go to step 5, and notice I is 9, whereas n minus j is actually, n is 9, j is 1, so 9 minus 1 is 8. So 9 minus 1 will give us 8, but i's value is 9, so 9 is not less than 8, which means we are done with the inner loop. So we are done with the inner loop because we reached the end value of I. So which means we compared all the elements in one pass, and notice what also has happened, we have sorted one element, or we have bubbled the maximum element to the end of the array. So cool. Now notice that we have our sorted array at the right side and unsorted array at the left side. So unsorted array still has 8 elements, and sorted array has 1 element, and this is when we called as end of the pass, which means we are done with the inner loop, and we go to the second round of the outer loop of j. So let's go ahead and run through the outer loop. So once the inner loop breaks, we again go, we will reach step 2, where our j's value will be incremented. J was 1 earlier, so now j value will become 2, and also we call this as start of pass 2, because this is the second time we are going through the entire array. So we are just starting going through the array again. So j is 2, which means n minus j plus 1 will now point to one less element, which means n minus j plus 1 will now point to 8, because we have 9, n is 9, j is 2, so 9 minus 2 plus 1, which is 8. So our n minus j plus 1 will point to 8. So this is just an indication that when our I will start, I will actually come and end here. So which means we no need to take care of the elements further, they are already sorted. So this is just an endpoint of I. So let's go to step 4 now. In step 4 we assign I equal to 1, and then we go to step 5 where the inner loop starts. So where we first see I is less than n minus j, I is definitely less than n minus j, because I will be less than till we reach the 8th element. So we go to step 6 now, where we compare AI with AI plus 1. So AI is 2 and AI plus 1 is 7. So notice 2 is less than 7, which means the elements are in order, there is no need to swap. So nothing to do here, we just increment I to the next value, I becomes 2, so I points to the maximum element 7 compared to the previous elements. And now we will again compare AI with AI plus 1, so which means we'll compare 7 with 4, and notice 7 is greater than 4, hence there will be a swap needed. So we will swap the elements, we have 2 4 7 now, I value will get incremented to 3, and now I will point to the element 7, and we will compare AI with AI plus 1, which means 7 will be compared with 3. So once 7 is compared with 3, because 7 is greater than 3, we need to still do the swap. The if condition will succeed, we do the swap, and then we end up with this array. So 7 now moves to the 4th position, and I we go to step 7 where we increment I becomes 4 now, and then we go back to the while loop again where we compare AI with AI plus 1. AI is 7, AI plus 1 is 9, and 7 is less than 9, so which means there is no need of swap. The elements are already in sorted order, both the elements, so we just need to increment our I and point to the latest maximum element, which is 9. So there is no need of swap, and we just increment I in step 7 and I points to 5, fifth element, which is 9. Now we again go to step 6 where we will compare AI with AI plus 1, but 9 is greater than 6, so we will need a swap here. So 9 and 6 will be swapped, so which means 9 will now move to the 6th position, and we increment I to 6. So once we increment I to 6, now I points to the maximum element till now, and we compare again I with AI plus 1. So 9 is compared with 5. Notice 9 is greater than 5. The if condition succeeds, so a swap will be needed. So we'll swap 5 and 9, and now we have this array. So 5 and 9 are swapped, and I in step 7 increments to 7 from 6, and we go to step 5 again where I is compared with n minus j. So in our case n minus j, because j is 2 now, so this is n minus 2. So n is 9, j is 2, which means 7. So I will continue till 7. I is pointing to 7 now, so this is the last iteration for I. So 9 will be compared with the next element, AI with AI plus 1. 9 and 10, in fact 9 and 10 are in order, so 9 is less than 10. There is no need of swap, and we increment I in the next step to 8. So now we increment I to 8. Notice what happens in the while loop. So in while loop I is 8, whereas I is only allowed to be till 7, because I is less than equal to 7 condition will fail, so we'll exit out of the outside while loop. So once we exit out of the outside while loop, we say that we are done with the next pass, this pass, which is pass 2, and we have pushed another maximum element to the end of the array, or we have pushed 2 elements now in pass 2. So we are at end of the pass, so we now have 7 more elements remaining, and 2 elements are sorted. So cool. So this is the second pass. So let's go ahead and see pass 3 now. In fact, what we will do is, since we know the basic strategy now, we will probably skip some of the very internal steps in the next few iterations, because that is probably pretty clearly understood now. So let's see what happens in pass 3. So in pass 3 we will have j point to 3, n minus j plus 1 points to the third last element in the array, which is 7th element, because j is 3, 9. So j is 3, n is 9, so 9 minus 3 plus 1, which is 7. So basically this is the end of the I, so I will range from I equal to 1 to 7 in this case. So we go to step 4 now. We start with I equal to 1, and we compare AI with AI plus 1. So 2 and 4 are compared, they are already in order, there is no need to swap. So we go ahead and increment I to 2. When we increment I to 2, now I with AI plus 1 will AI and AI plus 1 are compared. 4 is greater than 3. We will need a swap here, so we swap. So we have 2 3 4 now. So and I points to I becomes 3, points to the third element. So next 4 will be compared with 7, AI with AI plus 1, and we notice that they are already in sorted. There is no need to swap. So we will move ahead with I equals to 4. And with I equals to 4, AI and AI plus 1 will be compared, and notice 7 and 6. So here we have out of order, because 7 is greater than 6. We need to swap them and move 7 to the 5th position. So we swap them and we move 7 to 5th position. I now points to 5, And now we will again compare AI with AI plus 1, 7 with 5. 7 is greater than 5, so we have to again push 7 to the next position. So we'll swap 5 and 7, and then we have I equals to 6 now, and the maximum element till now 7 at the 6th position. Cool. Now let's compare AI with AI plus 1. Notice 7 is less than 9, there is no need to swap, and there is no need to swap. And now what we do is we increment I again, and notice what has happened. Now we reach our end of the position where I is, so which means I maximum was allowed to be 7. Notice what was n minus j plus 1. I'll write it again. 9 minus 3, j is 3, plus 1, which is 7, and I will become 7 now, and 7 is less than n minus 3, which is 6. Sorry, 7 is not less than n 6, so which means our inner while loop will end here, which means we have pushed another element to its end. So 9 is also now sorted along with 10 and 11, and in fact yeah, there is no need for this condition here, because we already have broken the while loop now. So what we have is we now have 3 elements sorted, and we have reached the end of the pass again. So we have done with 3 passes now, and in 3 passes we have pushed 3 maximum elements to the end. So there are 6 more elements remaining, which will take 6 more passes. So let's go ahead and continue with the next passes. So in this pass, so now we will go to through pass by pass. We will not see individual steps that we had. So in the start of the pass 4, we have 3 elements sorted. J now points to 4, and minus j plus 1 will point to the last sorted element, which is 7, and we start from I equal to 1, and we compare adjacent elements, which means we'll compare 2 with 3, 3 with 4, 4 with 6, and so on till we push the maximum element to the end of the array. So in the first case 2 is less than 3, and there is no need to swap. But notice even with 3 and 4 there is no need to swap, but swapping will be needed when I equals to 4. That is where 6 and 5 will be compared, which means AI with AI plus 1, and we need to swap those, which means we swap them, and then we will end up having 6 in place of 5. And finally at the end of the pass, what we will have is we will have the maximum element of the unsorted array, which is 7, in its position. So which means 7 will now be pushed to the end of the sorted array. So we now have 4 elements sorted as end of the pass 4, and we will have 5 elements remaining as unsorted. So this is the end of pass 4. So let's see in pass 5 what happens. We start with this array. J points to 5th element, and minus j plus 1 also points to 5, which means our I will end here. So now we start with I equal to 1, and what we do is we try to push the maximum elements. We compare 2 with 3, 3 with 4, and so on. So 2 and 3 are compared, and notice we don't need a swap. Similarly in the next I iteration, 3 and 4 will be compared, we won't need a swap, and we will keep doing that. In fact there are no more swaps needed because all elements are already sorted. So we'll keep doing that till we have the maximum element, which is 6 at the end of the array, at the end of the pass, and I will point to the last element, and then what we have is we have added one more element to the sorted array. So at the end of pass 5 we have sorted 5 elements, and the 4 initial elements remain. So this is how it looks like at end of pass 5. So let's go to pass 6 now. So pass 3 j will be 6, sorry, pass 6 j will be 6, and minus j plus 1 now will point to 4 because n is 9. 9 minus 6 plus 1, which is 4, and I will start here at the first position, and I will end here at the 4th position. So during this 4 comparisons or 3 comparisons that we have, we will push the maximum element to the end. In the first case 2 and 3 there's no need to swap, but at the end of pass 6 what we will have is we will have pushed the maximum element, which is in this case 5, will be pushed to the end with no more swaps of course. And we now have 6 elements in sorted. And then we start with pass 7. So in pass 7 we will, and j will point to 7 and n minus j plus 1 will point to 3. So which means we have to now find the minimum element of these 3 and then replace it at the third position. So 2 will be compared with 3, 3 will be compared with 4, and finally we'll have 4 in its sorted position. There is no need to be swapped here because elements are already sorted. So this gives another element as sorted, and we now have 7 elements sorted. So j value has become 7, pass 7 has ended, and we have only 2 elements remaining. So end of the pass 8. So pass 8, j will point to 8th element, n minus j plus 1 will point to 2 second element, and I will start from 1, and I will be compared with I plus 1, which is 2 is less than 3, no need of swap. And I will now increment to 2. Once I increments to 2, this is the last value, and our inner while loop will break, which means we have added one more elements in its sorted array. So we now have 8 elements as sorted and only 1 element remaining after pass 8. So 1 element is remaining, which means we don't need to do any additional comparison. Actually j is 9 and minus j plus 1 will be 1, so I starts from 1. So and I will end here because this is a once I increments, the inner while loop will fail. So which means we have now in the 9th pass sorted the 9th element as well. So we now have 9 elements sorted, and which is the end of our sorting algorithm. So we have the final sorting array. So basically in 9 passes we sorted 9 elements, 1 each in every pass, and at the end we had the final sorted array. Cool. I hope this description or detailed explanation really helped in understanding the algorithm. If it didn't, I would recommend you to go back and again watch the video. Otherwise just post a message or a comment and I'll definitely try to work on explaining it much more better if needed. So cool, let's move ahead and now go to next topic, which is optimization. So if you followed the last example which we were sorting, notice what happened. So probably after pass 5 we had this array. So we had 4 elements sorted, which means we started with pass 5 now. And if you would have noticed, after pass 5 after pass 4 we really didn't need to do any swaps at all. So our array which we had, that turned out to be already sorted 2 3 4 5 6, and there was no need to do any swaps in any more passes. We went through the passes, but it was really not required. So there is one trick using which we can optimize the algorithm to run a little bit faster. Now that is, if in a pass we went and compared all the elements, which means adjacent elements, and noticed that there is no swap, then we really don't need to continue to the further passes. Why? Because we already, if there are no swaps, that is an indication that elements are already in sorted order, and if elements are already in sorted order, we really don't need to continue any further. So that's why we unnecessarily ran through pass 5 6 7 8 9. It was really not needed. So that is one way to optimize the bubble sort algorithm. So notice what happened in pass 5. We started with I equal to 1. There was no swap needed because 2 is less than 3. We incremented I to 2, and this should be I equals to 2, and still there was no need to swap. We again incremented I to 3 here, and there was no need to swap again. We incremented I to 4, there was no need to swap. Finally I became 5 here, and there was still no need to swap. So since there is no need to swap, we could have just ended the outer for loop as well here, and saying that we already have a sorted array. So no swap in the entire pass, which means we can stop the outside for loop and we can say we are done. So this is the modified bubble sort algorithm, which looks like this. So everything is same, what we just have an additional variable, boolean variable swapped, that is inside the outer for loop. We start with swapped is false, which means we will say there are no swaps, and we go to the inner for loop. In the inner if condition, if there was a swap, then we change the value of swap to true, and at the end what we do is, now this is the outside, so this if condition ends here, or the inner for loop actually ends here, and at the end of the inner for loop, so I have changed the while loop to for loop a little bit, just so that we don't have to mention I equals to I plus 1. So once the inner for loop ends, we just do a check if swapped was false, so which means we really didn't do any swap, we just break from the outer for loop, which means we just don't need to continue in the algorithm any further. So this is just a small optimization which can save us a few outside for loops if the data is already sorted. So let's say if our data was already sorted, completely sorted, then what will happen is the inner for loop will just run once, and we will, because there is no need to swap, the outer for loop will break. So in short, we will be just done with one single pass. That's a great achievement in terms of performance. Cool. So let's now move ahead and do a complexity analysis or performance analysis for the bubble sort. So we are just doing in the similar way as we did before in the insertion sort and selection sort videos. So we have two loops here in bubble sort. We have the outside for loop, which is I equals to 1 to n, that runs n times. We have the inner while loop that runs from I equal to 1 to I equal to n minus j, so roughly about n minus j times. Even if we have the for loop here, which we had in the modified optimized bubble sort, still it will be n minus j times. So basically we have we have one loop inside of other. So let's see what happens in an average case. So in an average case means data appears in random order, which means it's neither sorted or unsorted. So what we are doing is, even though we do a swap or we don't do a swap, what we do is we do comparisons. We do adjacent comparisons every time we run the inner loop. So for the first case, when j equals to 1, so j equals to 1, our I starts from 1 to n minus j. So n minus j is now n minus 1. So in this case we have to compare the first element with the second and so on. So we do n minus 1 comparison in the first iteration of j, so when j equal to 1. Similarly, when j equal to 2, we have to compare one less element, which is n minus 2. So in the example which we had 9 elements. In the first j iteration we compared 8 elements, in the second we compared 7 elements, in the third we compared 6 elements, and so on. So when we have n elements, so we'll have n minus 1, n minus 2, and like that till 1, so which will mean the total number of comparisons is n into n minus 1 by 2, which is nothing but order n square. So that is the average case complexity. The same is the complexity for worst case as well. So worst case is when the array is reversely sorted, which means we need to do a lot of swaps, even though the number of swaps will vary between average case and worst case, but the comparisons will still remain the same, and we'll still need to do the same amount of comparison, and hence for worst case also the complexity is order n square. But let's see what happens in best case. Now in the best case, consider we have the modified bubble sort algorithm where we have the variable swapped, and if we see that the variable, if we see we no longer made swaps, we just break. So in this case, if we have an array that is sorted, what will happen? So there will be no swaps in the inside loop. Why? Because the elements are sorted, which means our the value of swapped will be false, and we will just break from the outer loop. So we are just done, which means we just completed it through one pass, which is nothing but we just went through all the n elements one, and hence it's just number of comparisons which we did was just n, or this is order n time. So this is the performance of bubble sort. In fact, bubble sort does very good when the array is sorted. We can just sort the entire array in order and time. Cool. So I think that's all I have for you guys in this video. That was bubble sort. I hope I made the explanation pretty clear. If you guys have any comments, any suggestions, please put it down on the video and I'll make sure to attend to it. So before we end, here is an exercise for you as always. So there is an array given to us. I think it has 10 elements, and do the sorting using bubble sort and just list down the total number of comparisons that was needed. So when we are going through every pass, make sure you add up all the comparisons you did in the inner loop and then add the total comparisons, and then post the solution or post the answer in the comment, and I will look at it and verify if that is correct or not. Alright guys, so this is the end of the video. Thanks for watching, and if you guys like my videos, make sure to subscribe to the channel so that you get notified of the new videos. Bye for now, and see you again in the next video. Thank you.